So now we're going to look into 4.1, get into chapter 4 where we're talking about probability distributions. In particular, in this section, we're going to be looking at what are called discrete probability distributions. And what that means is we're going to be starting to talk about the things we've seen so far in terms of things called random variables. That is, variables whose values are determined by some probability, some chance process like what we saw in chapter 3, where we're going to be recontextualizing these things in terms of a notation where we're going to refer to our values now with things like x, where we're going to let x stand in for some sort of event, and we're going to talk about forming formulas in terms of these values x and being able to predict certain behaviors and talk about probabilities of complex things that might be difficult to discuss just as they are. And I understand that when you see x and you hear about math, even though stats isn't really a math class, it's kind of its own thing, your mind probably conjures some images from middle and high school of chasing values around and doing manipulations that didn't seem to make a great deal of sense or always have a great deal of purpose and may not have always been very interesting to do because, well, frankly speaking, a lot of middle and high school math isn't that interesting. Now, I'm not saying that all the math at this point has been bad and worthless, or that all the teachers you've had up to this point have been bad and worthless, and I'm sure they were all trying their best to make the stuff interesting and worthwhile and as good as they could for you, but the fact is that we're stuck dealing with layers and layers and layers and layers and layers and layers and layers of bullshit that's put into place by bureaucrats that have no idea what we're trying to do, and it's just keep getting into our way and making things harder for us. But anyway, what I want you to understand here is that you don't really need to be nervous about the fact that we're introducing these x's back into the problem, as it were, because when we're talking about these values x for our random variables, as it were, we're still talking about the same sort of things that we saw in chapter 3, just with a little bit more notation so that we can take things in a more formulaic route. X is still just an event. So that event can be drawing a card from a deck, or rolling a die, or selecting a person from a study on blood types. Nothing in here is necessarily brand new. It's just we're going to frame it in this specific, more mathematical way because through years of work, years of research, years of study, we've seen that a lot of data, a lot of variables, that is, a lot of random variables, happen to fall into nice repeated patterns that we can characterize more usefully in this way than if we just wanted to take that great big pile of information and sift through it piece by piece. If we want to talk about things that could happen with card drawings, we'd have 52 options just for one, and as we've seen, that number gets very big very fast if we want more than one thing, and usually we do.
It's literally the 9 of spades, one out, and one out only.
Three-sider?
Oh
my goodness.
Oh, and
But
just ran out of his seat.
Because we have so much work with that, there are nice patterns that we can take out of it to make our life a little bit easier, a little bit cleaner, working with these distributions instead. And the next thing we're going to see is a quick bit on how we can classify these distributions in terms of whether they are continuous or discrete.